Welcome back to Roland Tutoring. If this is your first time joining us, be sure to take a moment and hit the subscribe button. If you would like to have your homework problem solved on our channel or to inquire about tutoring, please contact us via one of the methods listed in the video description. Today we are looking at a fluid mechanics problem. The problem statement is as follows. At a depth of 8 kilometers in the ocean, the pressure is 81.8 MPa. Assume that the specific weight of ocean water is 10.05 kilonewtons per meter squared, and the average volume modulus is 2.34 times 10 to the 9th newtons per meter squared. So our first part of the problem asks what will be the change in specific volume between the surface and the depth. So to get started, I have made a small sketch here to show at our surface we know the specific weight. We have our depth listed here, and at point 2 we have our pressure. So to go ahead and get started, we will need to find our specific volume, which if I pull out our equation sheet, we know that V equals 1 over density. So our volume equals 1 over density. Gone ahead and plugged that in here. So our density equation, if we also look at that here, is specific weight over gravity. So if we put 1 over that, that actually turns into gravity over our specific weight, which you can see I've done here, gravity over specific weight, which in this case is 9.81 over our specific weight of 10.05 kilonewtons. I've gone ahead and changed that into newtons here to give us 0.000976 meters cubed per kilogram. As we move forward here, we can then look at our next equation of our delta V, or V2 minus V1 over V1, equals our change in pressure over our bulk modulus. So we're looking at the change in specific volume, so V2 over V1, or V2 minus V1 over V1 equals our change in pressure over our bulk modulus. So we can go ahead and do that by figuring out that our delta V will equal our, which is this V2 minus V1. Oh, and then if we plug into this equation down here, we still don't know our delta V, so we'd have delta V over 0.000976 equals our change in pressure, which is P2 minus P1, which we have 81.8 times 10 to the 6th minus 0 at the surface. And all of that is over our bulk modulus, which is, or volume modulus as said in this question, of 2.34 times 10 to the 9th. So if we go ahead and work that out, we can actually multiply this number up here. And if we work all of that out, we get that 0.000976 times 81.8 times 10 to the negative 6. So our delta V becomes a 34.1 times 10 to the negative 6th meters cubed per kilogram. So that is answer 1. Now if we go ahead and pick the next question of what will be the specific volume at that depth, we can go back to our equation of our V2 minus V1 over V1, or in this case we already figured out this portion, or our delta V, because we figured out delta V here. So we can go ahead and say V2, which we would say V2 minus V1 equals our delta V. Or we can move it over to say V2 equals V1 plus delta V, which in this case we would have V2 equals 0.000976 plus our delta V of negative 34.1 times 10 to the negative 6th. If we go ahead and add those together, you will end up with a V2 equal to 0.000942 meters cubed per kilogram. Now our final part of this question is going to be, what will be the specific weight at that depth? So again, we need to come back to our equation sheet. Where do we find specific weight on this sheet? We have a specific weight here that we could potentially use. We also relate density to volume here. So we will do a combination of these two equations to come up with the equation of our specific weight of our second point here equals gravity over volume 2. Like I said, that is a combination of that density equation and the volume equation. If we go ahead and plug that in, again, we've already stated gravity is 9.81. Our volume 2, we've just figured out right here, which is 0.100942, which will then give us 10,410 newtons per meter cubed. And if you would like to turn that back into kilonewtons, you could have our specific weight 2 equals 10.41 kilonewtons per meter cubed. And that will be your final answer. If you have further questions on fluid mechanics, would like to have your homework problem solved on the channel, or would like to reach out for additional tutoring, please contact us using one of the methods listed in the video description. Otherwise, please take a moment to hit subscribe and leave a thumbs up. Thank you so much for joining us, and have a wonderful day.